Hello friends, welcome to our RV YouTube channel. In today's session 29 of electric drives and control, we are going to discuss about speed control of a three-phase induction motor by means of using a stator voltage control through a three-phase AC voltage controller. So now let us discuss about the contents of today's session. So in today's session, we are going to discuss about introduction, followed by the speed control of a three-phase induction motor, followed by the speed torque characteristics of a three-phase induction motor when it is controlled by means of using stator voltage controller. So now let us discuss about the introduction. So the a three-phase induction motor can be controlled by means of either from the stator side or from the rotor side. So in today's session, we are going to discuss about a speed control method from a stator side, that is stator voltage control. This stator voltage can be controlled by means of using a three-phase AC voltage controller. So by means of varying this stator input voltage of a three-phase induction motor, we can control the speed of a three-phase induction motor. This stator voltage control method is best suitable for a fan type of load whose speed torque relationship is of load torque is equal to K into omega m square. Here TL represents the load torque and omega m represents the speed. Here K represents the constant. Now let us discuss in detail about the speed control of a three-phase induction motor which it is connected to a fan type of load using stator voltage control method. So here this ABC represents the three-phase AC input voltage. This three-phase AC input voltage is fed to the three-phase AC voltage controller. Here thyristor T1, T4, T3, T6, T5 and T2 forms the three-phase AC voltage controller. By means of controlling the stator input voltage of this three-phase induction motor, we can control the speed. So let us see how it is being done. Here V represents the stator input voltage and T represents the torque. So according to the equation 2, for a three-phase induction motor, torque is directly proportional to V square. That means torque is directly proportional to square the times of the stator input voltage. So according to the equation 1, when the firing angle of the three-phase AC voltage controller is changed, the RMS output voltage of the three-phase AC voltage controller changes. So this change in three-phase AC voltage from the three-phase AC voltage controller is fed to the stator input of this three-phase induction motor. So what happens is when this three-phase AC voltage, that means the RMS value of the output voltage of this AC voltage controller changes, then the stator input voltage of the three-phase induction motor also changes. So when this stator input voltage V of the three-phase induction motor changes, then torque also changes. So, as we already discussed, this stator voltage control method is best suitable for fan type of load. So for a fan type of load, the speed torque relationship is given in equation 3. So according to the equation 3, if there is a change in the torque, then there will be change in the speed. Here T represents the torque, K is a constant and omega m represents the speed. So if there is a change in the torque, then there will be change in the speed. So this is how the speed can be controlled by means of using the three-phase AC voltage controller through stator voltage control method. Now let us discuss about the speed torque characteristics. So here this omega m represents the speed axis and here this T represents the torque axis. So here this purple line colored characteristics is a typical speed torque characteristics of a three-phase induction motor corresponding to the voltage V1, that is the rated voltage. Okay, and here this line represents the torque characteristics of a fan type of load. So this point where our motor torque will be equal to the load torque, which will be operating at a steady state operating point. So according to this point here, this is our speed omega 1 corresponding to the rated voltage V1, and this is our torque T1 corresponding to the rated voltage V1. So for some reasons now we want to control the speed. So for that what we can do is we can reduce the voltage or control the stator input voltage of this three-phase induction motor by means of varying the firing angle of this thyristors of this three-phase AC voltage controller. So if we change the firing angle, what happens is the voltage V1 is reduced to V2. That means we are reducing the voltage here. We are controlling the stator voltage, means we are reducing the voltage here from V1 to V2. So this blue color line is the speed torque characteristics of a three-phase induction motor corresponding to the voltage V2. That means for the new voltage, for the reduced voltage. So according to this operating point. According to this new operating point, now the operating point will shift here. So according to this operating point, our speed will be omega 2. So if you observe omega 1 and omega 2, the speed is reduced. So this is how we can control the speed of a three-phase induction motor, which it is connected to a fan type of load using stator voltage control method by means of using the three-phase AC voltage controller. In next session 30, that is under part 2, we will discuss how this three-phase AC voltage controller controls the AC voltage. That means how it converts a fixed AC input voltage to a variable AC output voltage with the help of the waveforms. Thank you.